Okay, so we will select create a new flow model. Uh, here it really doesn't matter. Like here you change this today. You select the units, the projection, that's just arbitrary. So anything really. All these details are not important. Here, if you want to add a model description, not important. Uh, and here you just like select the model. So this is important. Like if you don't have MudFlow 6 and you select the MudFlow 6, it's not going to run. So you need to select what you have, which is MudFlow 2005. Yeah. So that's like MudFlow 2005. Uh, I think like you can just keep all this to 0. Here you can put like this detail, like the model has one layer, so you specify that it just has one layer. And then now it will tell you what is the upper aquifer. So you put this like here, the bottom of the aquifer. The model top, sorry, it's like the model upper aquifer, yeah. Bottom elevation of the um, yeah, that's the model top, and that is the upper aquifer. You only have one of it, so it doesn't matter. So so the upper aquifer, like you can start it like here, and then the model top that would be 120, and just make it high enough. Like if you look at your head data, that is, it tells you like they are all around like 110, 111. So you just put something much higher so that you will not. So like your groundwater table, like you give it, and this one is like giving in your whatever in your project. I'm telling you this is at 90, and then you create no grid, and then you create OK. Once you start this one, when you start this one, it will always show you like a random tutorial video, so you can watch it. So, so whenever you start it, it will show you like a random tutorial video for you to watch if you like. So yeah, like in this site, it has several tutorial video. One of you, I think, was asking like, can I like do transport modeling? If you want to do transport modeling, we are not covering this in this class, but like watch some of this tutorial video and exercise, follow it, and then you will be doing a transport modeling exercise, and then you can adjust it for your case. Yeah. But the transport model, it will like before you have a transport model, first you need to have a flow model. Because remember, like your transport equation, it has velocity. Where are you going to get this velocity from? That's from your flow model. So you cannot have a transport model without a flow model. You need first to have a flow model. Flow model, remember the flow model, it will simulate the head for you. And if you know the head from Darcy law, you can calculate the Q. And then from the Q, if you know porosity, you get velocity. So basically, so what like if you run the transport model, what the transport model will do, it will take the head generated from MudFlow and it will calculate the velocity based on the porosity that you give. Yeah, that's and then you can run your transport model and simulate contaminant transport. Any question about this part, like running like and the transport model that goes with MudFlow? There are many of them, but the ones that's commonly used is called like MT3D. And the new version of it's called like USGS. That's the one with MudFlow 6, and it can do like saturated and unsaturated, like not just the saturated zone, but like the unsaturated zone also. Yeah. But anyway, so once you start Model Muse, it will give you something like this, yeah, and and then it will, and then we can start like I think the first step is like we can import an image and create the grid. So to do this, like you come here, you open. Do you want to save a change made to the model? Yes, I want to save a change made to the model. So I already have it here saved. Like I will just call it. Where is that? Let me just see. 2025 lesson project file. Yeah, okay. I will just call it MS like model setup, and I just like save. You want to replace it? Yes, I will replace this. Oops. doesn't like it. I don't know what happened here. Okay, so yeah, so I already have it saved as MS, and then I will come here, open. Do you want to save a change made to? Okay, yeah. You want to create? I mean, I don't know what's happening here. Let's just like okay. So I will like go to these files. So these files I have them downloaded somewhere. Numerical model. So this is the project files. Uh, I don't know where these files are. Let me. Okay. File, import, and then let's say like image. Select image. You select the image. Oh, okay. Here they are. So I'm not sure if this is the ones that I really need. Yeah. So is this one? Yeah, it was the K value. Yeah. This is a better one. Okay. So yeah, so I just like put this here, and for this one I just like need to add like a coordinates for it, like for my site, like say like where is the 00, and just like put this to scale. So so if you did this, like you can just like come here, select like this corner, for example, and then it will, that would be like my 00, yeah. And then I could just like come here, select this point, and that would be like x is 0 and y, I think it was giving 1500. Okay. Uh, and then I can select like this corner here. X would be like it's 4.5 kilometer, and the y is 0. And then the x would be 4.5 kilometer, and the y would be 1.5 kilometer, something like this. And I think it looks okay. Like sometimes I just try to adjust this number, so just to make them aligned. Yeah. I mean, just really doesn't matter. Something like this. Yeah. So all these corners are now uh, like so. This pixel correspond to 00. This and this correspond to this, and so on and so forth. Yeah. And then like if you clicked OK, then like you see here, you have it like very small. Like you need to make it like a little bit larger. And then this software is a little bit not very user friendly, but maybe a little bit smaller. If you have a mouse, it would be easier to deal with it because like you can scroll. Well, anyway, so that is what we have here. So we had this one. The next step is that like we want like, so we have like an image, we kind of like georeference it, like scale it, so with the distances that we need. Uh, Uh, but that's what we did, and then like create a grid. So like to create a grid, like so here, like that's the software. It has like different, like if you want to create an object, it has like you can create a rectangular object, you could create like a straight line object, you could create like a polygon object, or you could create a polyline object, or you can just create a point object. Point object, that would be a pumping well, for example. Yeah. Uh, Polyline objects, that's for example to draw your hydraulic conductivity. For your site, you can just select like a rectangular object, and you can just like come here. Oops. You can just like come here and like click OK, and then it will give you the object. And then once you have the object, you can give it a name. So in that case, let's just call it this like outline. So you can call this like outline. And now for this outline, uh, we can here see this is like the higher z coordinate and the lower z coordinate. So since we are using like this object for creating our grid, then we sometimes you have like different layers in your models, but in that case we only have one layer in our model. So we need to select this, like what is the upper z coordinate of this layer and what is the lower z coordinate of this layer. So you select here, and see, that's what I will telling you, like this software is very strong. You can do some programming here, but in that case we just do simple stuff. Like, so you will just go here. I think that would be under data set required layer definition. So the top z coordinate, that would be the model top. I think you need to double click on it, and then it will appear here. But you can do programming if you want. Like you can say model top plus something or minus something. You can put an if condition or whatever. Yeah. But in that case, we're not going to do this. We'll just something simple. And then the lower Z condition, that would be the aquifer bottom. Yeah. Oops. You have to come here. You have to double click on it. It will appear here. Then you click OK. And then we set this. So we define now like the Z coordinate. Now we need to define the XY coordinates. And yeah, use this to set a grid. So we are selling like this is the ones that we will use for setting the grid, and the grid size that would be like 50. Yeah. And then here you can there's this, we can skip all this. Like here you just adjust the vertices, so that should be 0. Like that should like, because remember when I draw this triangle, I didn't draw it exactly on like my side boundary. I just draw it outside. Yeah. But I can adjust this manually. Like, do you understand this step? Yeah. So I can just adjust it manually. So I can put this here, can put this like here, and you will know like what you need to do. Like this is here, this is here, this is here, 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 and here. And you can check if, oops, is this correct or I did something wrong here? I'm not sure which is this fifth one for. Hmm? Yeah, ZB5, okay. Yeah, yeah. But anyway, so it looks something like this, yeah? So you have like something that looks like this, and then so like, oops. Oh, did I deleted it? Oh, I think I deleted it. Ah, I think I deleted it. Let me do it again. Yeah. Okay. Or maybe I didn't. Let me just check. Like, I think you can come here. There is sure hide object. Yeah, I don't have any object, so I think I deleted it. So yeah, so I think you come here and that will show you like all objects, but I don't have any objects. This means that I deleted this one, but let me do it again. Let me just do it quickly. So like you come here, call this outline, use to set grid, set it to 50. Um, model top. Come here, you click OK, and oops, that's okay. So I don't want it deleted this time. What if I clicked it? Oh no. Okay, so let's click on here, and then if I clicked on this object, then it will appear again. Okay, that's like the tricky part. Like you have to change like to this one, and then if you clicked on it, and then it will appear again. And then let's see here. We did this 50. We did this here. This is 0. This is 0. This is 450. This is 450. This is 0. This is 1500. 1500. This is 0 and this is 0. Okay. And then click OK. So I think that should be okay, like so. Yeah, that should be okay. Like the grid, I think we can generate it like later in another step. But let's see our object. Like if we click here in our object, uh, we have like, yeah, see this one. So that's like how you could show it or hide it. Yeah. But let's keep this one close. Okay. So that is this step. Lower Z vertices, adjust to generate grid on. Okay. Uh, create like a hydraulic. I see. I think we will generate the grid later, right? Like where we will get the actual grid. Uh, because I don't know why I cannot see the grid here. Like usually, like when you did this before, were you able to see the grid once you said like generate grid? This one? Oh, this, okay. Yeah. Oh, generate grid, okay. Oh, generate grid icon. Okay, yeah. Yeah, so that's generate grid icon. Yeah. Yeah, it was written here actually. Yeah, see, like in this step, it's written here. Yeah. So like you generate grid item, and this will show you like the this side, and this will show you this side, like the depths, like. But in that case, we only have one dimension, so it really doesn't matter. Yeah. I mean, only one layer. Yeah, it's only 2D model, so it's only one layer, so it doesn't matter. Uh, and then like after this we need to define like our hydraulic conductivity zone, and to do this, I think like the steps that I wrote here define 6 parameters for 6 zones. So we want to define like 6 hydraulic conductivity zone, and then from model we go to what did I say? Like from model create like manage parameters. Yeah, go to manage parameters, and then you define like your hydraulic conductivities here. Like, oops, we need 6 of them, and oops, like K1 for example, K2, K3, K4, K5, and K6, and uh, oops, let's just do it maybe one by one. K1. Okay, the type, hydraulic conductivity, the packages, and then the value you put like 8, for example. Okay, the value should be 8. Okay, here you have like K2, here you have K3, K4, K5, and K6. And basically you are just define whether this is like hydraulic conductivity, vertical anisotropy, horizontal anisotropy, vertical hydraulic conductivity, or this one, whatever that is. Yeah. Did we select MudFlow 2005? Yeah, and that's why I see that is the package LPF. That would be like the package for like in MudFlow 2005. In other MudFlow, that would be like different packages, but that would be the package that would be used. And then like we put these are just our initial guess for our hydraulic conductivity value, and we got this from our pumping test data. So that's like the previous homework you did where you uh, use pumping test data and just found some. So this would be like, so the model, like the initial run of the model, which will use this hydraulic conductivity value, and then we keep it changing it until we get like a good match between what the heads that the model is simulating and the heads that we measured in the field. Yeah. And then your parameter. Okay, so we define like the hydraulic conductivity value. And then now we want to create like a different hydraulic conductivity zone, and for each zone we assign it to like one of these values. So uh, in that case, you can just like select like this guy here, for example, and oops, can just do it anyway. Like okay, so I will call this maybe K1. I will just give it a name like K1, and it's just like now this is where this layer is in the data set. That would be like require, and I think like for this one you select like KX. This is the correct, yeah. In the data set required, or is this like how we, let me just read here how to do this. So like your parameter, use the parameter to define hydraulic conductivity field, create a polygon object, name it name like I call it here Z1, like okay, I call it here Z1. That's even like, let's keep it Z1 so not to confuse it with hydraulic conductivity value like zone 1, yeah. And then go to required hydraulic conductivity parameter re required. This is, I don't see this here. Create like name required. So that's okay. This is the required. And then go to the create required, select parameter is false. I don't see this here. Yeah, like maybe something here I need to change. Uh, okay, let's just see like define parameters. Use so this is use the parameter to define hydraulic conductivity. Create a polygon object. Name it this. Data sets. Oh, you go to data sets. Yeah, but that's what we did. Yeah, you go to data sets. Yeah, it's only showing this hydrology. Yes. So. Let me go here, model parameters. Maybe it didn't say, oh, they are here, yeah. Did I miss anything here in this one? Manage parameter, key value, but no, like you create this zone array, but it does not say here to do this. Ah, for all parameters. Okay, that's okay. I mean, sorry. I mean, I've been up very early in the morning today and just meeting back to back. So, so I was just like, yeah, yeah. I woke up very early today and I had like just meeting really back to back until now. So, okay. So at least now we are doing something. Yeah. But anyway, like we can come here. Let's do it again. Yeah. So like you come here, you come here, you come here. I mean, let's just do anything, doesn't matter. Okay, let's call like this zone one, and then data sets require. Okay, now we go. Here we go. So we have to you have to select like zone one and make this like true. Yeah, and then you have to collect zone two, zone three. You have to make like you have to select all of them and make them false. And because if you didn't do this, I think they can overlap them. They were overlap because sometimes like when you draw these things they could overlap together, so you just want to make sure that like whatever this polygon will do is only for like this parameter and not like the other ones. If you select like two of them, both of them true, it will overlap them and then it will take an average value for these two hydraulic conductivity. Yeah. So like here, like K1 until K6, like you're just telling him like for this shape, use K1 and all the other are false. If you selected any of the other one, it will take the other one and that one and that one. Yeah. But you just here, you don't want to overlap them. You just want to and then you select all the other to be false. Yeah. And yeah. But anyway, so you can do this one. Yeah. Yeah. And now let's do here. Yeah, so now here we have like zone. Yeah, ask me please. Yeah. Oh, yes. So if you want to change it, there is a way to do this, which is one of these things. I think so. Edit vertices value or insert vertices or delete segment or there's a way for doing it, but there is a way. Like I'm sure there is a way. Like I think maybe if you come here like edit vertices value. Where? Yeah, select vertices. Yeah, yeah. Yeah, yeah, you can change the zone, not necessarily. Yeah, that's a good question. Like you don't necessarily need just to change the number. You can change the shape of the zones, yeah. Until like you get like and that's exactly what the geostatistics method are doing. They keep changing the zones. They will keep generating like you have like a distribution to sample from and it will keep generating multiple image. Each image will show like different zone until you get like the right one. And then your final answer will not just be one answer, it will be also a distribution. Because some images, like not like some images are excellent, some images are good, and some images are bad. So you get a distribution, probability distribution. Like your final answer would be like a probability distribution, and like the best image, that's the ones that will have the highest likelihood. But the bad image, you should not eliminate them. Should be part of your. I mean, yeah, that's yes, like it's. But anyway, doesn't matter. Like these details are not important. Like what's important now is just like to learn this modeling concept and and then like later on in your career, as you do this more, like once you know the concept, like as you do this more, like you in your career, I don't think you would be ever doing anything twice. Or at least in my career, I've never done anything twice. Like everything is always like, for example, I use Mudflow, then I went to Hawaii, I use Sutra, then you go there, you use like FeeFlow, I never did anything twice. But what is common among all this is that I have this understanding of modeling. Yeah, and then I want to learn Sutra, then I get the manual of Sutra, I read it, same as Mudflow. Yeah. I mean, not same, but like if you know one, you can know the other. Yeah, and then so that's basically like so what you like. All these details are not important. Like the most important, like have this conceptual understanding, but like how to use this graphical user interface not important. You might not use this graphical user interface again, but and then yes, like and then once you learn it, the tool, like that was like the first model I developed like in my life. Actually, this was one homework I had when I was a student. Yeah, and then after this model I learned this, then you go for other more like sophisticated model because now you know the basics. Yeah, so I started with this and then you advance, yeah, to more things. Yeah. Well, so that's why all these details, like when I started with this one, I didn't know all these details that I'm telling you now, but like you learn it in your career as you go through your career. Yeah, like the student actually who took this class last year, she's now groundwater modeler at South Florida Water Management District. So if you, I mean, I'm not in contact with her, but if you contact her, she will be doing very advanced things. Yeah, things that beyond what we covered in this class. Alexis Aker. Yeah, yeah, yeah. That anyway. Okay, so let's keep moving here. Okay, so let's do all of them. I mean, I don't know if I can be able to see what we want to do here, but I think this is zone one, zone two, like the 21, and I think this was up till here. Yeah, up till here we did it. So let's just like I just create like one of these guys and I will maybe make up till here. I will call like this zone 2. Yeah. And for zone, oops, I will call like this zone 2. For this one, I will like select this one. I'll select all of them and I will make this true. Okay. And now, like you see, these ones are over, like, see, this one is on the top of this one. I want to bring this one on front in order to make like just this zone here, like with this value and the rest with the other value. Yeah. So to do this, I think you click on it and then maybe to front. Yeah. Just bring it to front. But we can do this at the end. Yeah. We can do this at the end after we do all of them. So this is zone 2 and zone 3, that's the 300. So I think uh, that would be like the one that goes I don't know how to do this one. Go something like these are like the high values here, like so this value, like this value here, which should connect to this value here, should connect to this value here, and it should be bounded by these edges here. Yeah, so you have like an edge here, you have an edge here, you have an edge here. It should be bounded by an edge. Okay, let's just start doing it and maybe we will. So I will like start it maybe from here, here maybe, and then up till like here, then up till here. Don't know where this end, but maybe here, maybe here, maybe here, 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 like I have an edge here, I have this edge here, I have this edge here. Maybe something like this, yeah, not bad. And then, oops, set data. Uh, here, 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 and then come to this one, make it a little bit true. Yeah, and then you click OK. Okay, not bad. Yeah, and then we need to do like what is the next one? The next one is the 41, so that would be somewhere here. So can just like click here maybe. Oops. Something like this. Then I call this like zone 4, and then you come here. 1, 2. Oops. You just click on this one again, zone 4. 1, 2, 3, 4, 5, 6, and then this is true. Yep. Then you click OK. Okay, and then the next one is the high conductivity one here. So we don't know exactly what's happening here, but we can just come here, put this here maybe. Okay, and this is zone 5, and we come here. 1, 2, 3, 4, 5, 6. This is like true. This is okay. So, and then the last one, that's the one near the river, and we don't like this is like call it like the 151. Let's put this here. Oh, let's put it here maybe, or here, or here. The trick is you have to connect it to the other zone. Otherwise, if it's isolated, it will not be connected to the river will not be connected to these high conductivity zones. That's the trick here. So as long as it's connected to them, that should be okay. So oops. So like 1, 2, 3, 4, and then this like true. Yeah, and that's okay. Okay, so I think we have like this part, which is like the time consuming part, to to repeat the above step like okay. So I think yeah. Yeah, I mean this is a long thing. Like if you want to leave, feel free to leave. Yeah, or if you want to stop, just tell me stop. Yes, 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 yes. Yeah, yeah, yeah. Sure, sure. Yeah, yeah. Please, if you want to take rest or you want me to stop, just tell me stop or take rest or yeah, yeah. Yeah, yeah. So, so we have like this here up till this step. Keep repeating it. To view the hydraulic conductivity, we need to view the hydraulic conductivity. Field check the before we view the hydraulic conductivity field. Let's just arrange them first. Yeah. So before we view this, so that we don't like waste time. So here that should be bring to front. To back forward one. So this let's make this forward one, yeah. And then this guy for sure bring to back one. Yeah, make this the back one. And this big guy make this also back one, maybe. I don't know. Now they collapse together, but like uh, this one should be here, yeah. Uh, now this one should be brought to the front. No, here. This to forward, to front forward one. That should be okay. Let's just see it now. And if something needs to be adjusted. To view hydraulic conductivity field, check your assignment and arrange object data visualization icon or data visualization menu. So data visualization icon, I think it is this one. And then color grid, okay. And then data set. Okay, so color grid data set require uh, uh, KX, okay, uh, hydro hydrology in KX, and then click apply. Let's see what we have close. Uh, Not exactly what we want, yeah. I mean, this one looks good. This one looks good, but maybe let's do this one. Yeah, bring to front. No, let's do this one to back. This one. Maybe like I think maybe this one has an error in it. Like I said, this is false. This is true. This is false, false, false. So this is okay, but maybe so this one is okay. Let's just see this one. This is true, false, false, false. So that should be okay. Maybe it is like the color we cannot see it clearly, but at least let's continue here. Let's bring this one to back. Okay. So I think everything looks okay except for this guy here. I'm not sure why this guy does not look okay. Or it's just my eyesight. Yeah. Yeah. Let's do manage parameters. So yeah, I mean there are okay. Let's do a trick. Let's make it like 500 and see if it will like have a different color. Yeah, it's working. Yeah, just a different shade of blue. It's nighttime and we are all tired. I think that's the problem. It happened to me once. Yeah, I was once like before AI, like if you got stuck in coding, there was a site called like Stack Overflow. You used to ask your question, and then I was like doing a figure, and the lines were not adjusting. They seemed like at an angle, and I kept checking everything in my figure, and everything is just at an angle. And then I uploaded to Stack Overflow. I upload my code and tell them what's wrong here. And then one guy told me there's nothing wrong with this code. It's probably something wrong with your eye. You might see go stick its doctor. You might go see a doctor. So that's probably we might the three of us might go see a doctor. Yeah. So yeah. So where is that color? Where is that color? Yeah. Model. Yeah, model parameters. So we get back to 8. Yeah. Okay. So that's okay. That's good. Yeah. And then one thing you can also do, like you can come here. That could help us to see it better. And then you can see this is required. Like you can select like you can remove all these zones. Yeah. And now it looks a little bit better. Yeah. Huh? So like you come here, data visual like here, and then like if you want to show the zones or like you remove them. Yeah. So like so that looks okay because like you see this will be connected to the river. This will be connected here, here. This goes here. This like goes here. So I think that should be okay. Yeah. Okay, so we are done with this one. Like, so you can, yeah, you can unhide object, like hide or unhide. So this one for visualization. So now we learned this. So this is for data visualization, and this is for showing or hiding objects. And yeah, okay. So what else do we need to do? Add packages for boundary condition and head observation. Add packages for boundary condition and head observation. Boundary and head observation. Yeah, boundary condition and sources and sinks. So that's like your boundary condition and your sources and sinks, not just boundary condition, yeah. Or or yeah. Okay. So add packets that you use for the model. So okay. Yeah. Uh, so it says like go to model, modflow packages and programs. Uh, boundary conditions. Okay, boundary condition. Okay, so they consider like all your sources and sinks here as boundary conditions. Okay, so that's what we need. Like we need a recharge boundary. So that would be like your top boundary. It will define like the recharge. Uh, recharge boundary. You need like a river boundary, which is where is that? Is this here? Head dependent flux or river. I don't have this one here. Oh, head dependent. Yeah, it's a head dependent. Remember, like your river is like head dependent type 3 boundary. So that would be what I still yeah river package. Yeah, and then head observation. We also need to select like this observations. So head observation package Because remember, like your observation data does not necessarily need to be the head data. It could be anything. Yeah. Could be like your river stage that you could use. This is also observation. It could be like could be like a flux, like a flux that's occurring through your boundary. It could be that flux, for example, could be like discharge, like submarine groundwater discharge or spring discharge or whatever. Yeah. So these are all like in the model, for example, that I use in Hawaii, this model was calibrated using not just the head data, like the observation data was the head data, was salinity data, was a spring discharge. Because an important thing that this model, we wanted this model to simulate was spring discharge. So we had some measured spring discharge and we wanted to make sure that our model is reproducing the same discharge that we observed in the field. Yeah. So, so here these are example, but in this case we are just doing head. Yeah. Okay. So what else do we? And then well, do we select the well now or not important? We can select it now also. Yeah. Yeah. Well package and yeah. And then I think like we just selected them so that they will appear like we can input data to them. Okay. So we did this, and then we move to the next step. Now add recharge. So like now we want to add recharge. So again, like recharge, you will do the same thing. Like you will come here for your project, like for your design problem, you will create different recharge object to simulate like the industrial zones that you will add, to simulate like the nature-based infrastructures that you will add, and then you will change their location. Yeah, but it's the same. Like you just do it the same way. So like here, the recharge is over all the model, and I will call this like recharge. Yep. And then so this object is recharge. And how could I know that this is like recharge? Create an object name. Mudflow features. Yes, so now Mudflow features, I should have like a recharge package. So I will like upload this, like I will select this as my recharge package, and then yeah, the starting time. So the starting time is zero, sorry, is -1 because this is like steady state. Yeah. So usually we start like, so when we run like the model, like usually we run transient model because pumping is like goes over time, recharge could change over time, like as you saw like in the previous model, like the head was changing over time. But before we run like a transient model, we generally like run the model in a steady state. And that's why we select -1, like -1 to 0, because that is a steady state. That would be the initial condition for our recharge model, for our like transient model. So that's why it go exactly right, like goes from -1 to 0. That 0 will be like your initial solution for your transient model. Yeah. So that's just like a typical like modeling practice, but you can just add whatever you want. Yeah. So you put this here. Recharge. You make sure that like your unit, like you selected everything in day, so make sure that you will like in the report you are giving this in millimeter per day, so make sure to convert it to meter per day because that's what we selected. So 0, 0, 0, 8. So it's like 1, 2, 3, 4 zeros, yeah. And uh, so recharge, yeah, like okay, and okay. I think that's it. I think you don't need to do anything else. Like recharge rate. I don't think anything else is needed, so just like click OK. Yeah, so I was telling Esmer that we generally like starting time is from -1 because that's the steady state, and then it ends at 0. Okay, and usually like that steady state solution, that would be like your solution. Like when you run, like usually, like we run generally this model like in transient, like transient, because pumping is a changing, like recharge could be changing. But before you run like your model in a transient state, you generally first run it in a steady state, and that would be your initial solution. So, and that's why it goes from -1 to 0. And then like your transient model will start from 0, from this solution. Yeah. Okay. So that's like a typical practice. But and then like this is a recharge, and then you put OK. Okay, so now we have this here, and if we want to visualize recharge, I think we can do the same. Like we can come here, we uh, remove this one, and then we can come here. We can like instead of this one, like boundary, like you can come here to the boundaries. You can select recharge rate, and if you click apply, yeah. So, and I think like, see, if you click here, it will tell you the value. Like you see the value here at the bottom of the screen. Here. And that's the same with the hydraulic conductivity. Here. Like, see? Tells you the value here. It tells you like which row and column you are. It tells you like the X and Y coordinate. Like, so the X and Y coordinate is here. The number of row and column is here. And same for your hydraulic conductivity. Like for your hydraulic conductivity, you want to know what's the hydraulic conductivity. You just stop with your mouse here, and then it will show you the hydraulic conductivity value here. Okay, that's basically like how this works. Yeah, because like for your third case, your recharge will not look like this. Like your recharge, it will be like one zone in the middle, like that is impervious, and then whatever. Yeah. So and then like you to double check that you did it correctly, you just like do it here. Okay, let's move on. So this is the oh how oh just like you just like select here, like select object, and then like see as you pass here, see the X and Y is changing, the number of row and column is changing. The recharge value is not changing because it's the same everywhere. Oh, the green thing. Yeah. So the green thing, yes, so like you go to the, yeah, recharge. You select recharge rate. You select, like, let's do it again. Like, let's go to data sets, required, hydrology, KX, and then you click apply. No, I didn't select anything. Okay, let's do it again. So, like, you go here, require, hydrology, KX, you click apply, and then now, and then and then close, and then now like you see here my k value is a little bit, I don't know why my k value is not actually showing the actual value, it's just showing all these uh, oh actually no, it is showing the value. Like see at the beginning, at the very beginning, it's showing like 41. Like can you read it at the very beginning? 41. Like here at the very beginning 150, yeah, at the very beginning 21. Like here it's 8. Like see, you cannot see it as 8, but it tells us, like you see, can you read the 8? Yeah, at the bottom of the screen. Yeah, so that's how like you do, you know that you did what you wanted to do correctly. Okay, uh, so like add the river. So now like after we do this, like we can add a river. Uh, uh, Oh, to add a river, we need to first like subdivide the cell. Okay? Subdivide the cell because the river is only 40, like the width of the river is only 40 meter and each cell is 50 meter by 50 meter. Yeah. So in order to add the river, we need to subdivide the cell. Uh, so subdivide the column. Yeah, like to do this, I think you do here. No, generate grid. Subdivide grid cell. Yeah, display. Yeah, subdivide grid cell. So you click on subdivide grid cell. Uh, Let me just read it before I do it. Uh, to create subdivide column, rows, and layers, select the cells that you want to subdivide last column. Uh, Subdivide the grid cell, subdivide column, row, and layer. Select the cells that you want to subdivide, like the last column. Select subdivide column into 5. Okay. I don't know. Okay, here. I think you just like. Yeah, okay. I think. Uh, so subdivide each column into, let's just say 5. Then click OK. Yeah, so now we did it. Yeah, we just subdivided like the last one into 5, and we can zoom in and see it. Yeah, so we can zoom in maybe. Yeah, here it's about correct, right? Um, Now let's zoom out. Now what we want to do like the river. Is there a way to? Let me just put this down because we don't need these guys. Okay. If your mouse has a scroller in it, that would make things easier because you can scroll up and down, and that will zoom in and zoom out. But huh? Say it. Oh yeah. 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 That's annoying. Yes. Yeah. 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 Yeah, I mean, this software is not very user friendly, but it's free. So I mean, for being free, I think it's not bad at all. Yeah. 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 But but if you use something like GMS, which you will find in most offices, that's what they use, it's very nice and it has a lot of tutorials. So that's the good thing about it. Like now you understand like this basic, and then you use GMS, you will find that they have a lot of tutorials and videos and a lot of learning material. So and it's very like you can, like here you see we are doing all these things manually. There you can just have like GIS maps and like for your site and just automate so many things. Yeah. But so it will like you will like learn it like much easier than this. But this one, yes, this one, if you just want something for this class, I think this is perfect. Like for this class, like for the learning objective of this class, I think this tool is good enough. Yeah. uh, okay, so let's see what we are doing here. Okay, so add a river. Yeah, to add a river, create a rectangular object over the last 4 column. Okay, so now we need to make it a little bit bigger. I don't know how can I create an object over just the last 4 column. Okay, anyway, it doesn't matter. Like, let me try to do it. So here is 1, 2, 3, 4, maybe something like this. Oops. I think we can do it like this, and if you don't like it, we can. No, it looks good, yeah. Yeah, yeah, yeah. And if you don't, if you know, if it is not like accurate, like what you can do, you can just do whatever you want, and then you can edit it manually. Like you can just come here and then like go to the vertices and just start changing these vertices. But it's, yeah, I mean, but anyway, so that's like, it's not bad here. Like you can keep going here. Don't need to. Okay, so we come here and then like you click here on this one, and on this one, what do we do? Like we subdivide into create to add a river name, river mod flow. We can just call it like river here, and then mod flow feature. We select like a river package, and for mod flow feature, we select the river package, and then the same thing like start time, the one, end time. The river stage is 100 meters, so this is giving to you the conductance. So I showed you like how to calculate conductance in one of these videos and what does it mean. So you can check this. Like let's not spend time doing this now. And then river bottom. So that's like, yeah, you just put the river information here. Just want to make sure that I didn't. So the stage is 100. The conductance per unit area is 50. The river bottom is and then the conductance. Okay, I think this is important. Like you need to change this. Uh, yeah, this is like not calculated. This is direct. Like so, this conductance value interpretation, you're just giving it like the direct conductance value, which you calculated, not interpretation or anything. So conductance interpretation direct. Double check river stage from data visualization and boundary condition observation, not flow river station, remove visualization. Okay, so let's just do it, yeah. Okay, so here we have this. Like if you want to double check this, we can come here. Let's just we can come to visualization and then not data sets boundary condition. Come to river and then like we want to see the river stage or conductance or whatever. Let's just select the river stage, apply. And yeah, that seems correct. Yeah, like 100. Yeah. And like if you want to make sure here, yeah, like see 100. So like see this is 100, this is 100, this is 100, this is 100, and this is nothing. Yeah, so that's correct. Okay, so I think we are, so far we did this. Uh, so far we did this, yeah. Add a river, add a pumping well. Okay, so the pumping well, we can add a pumping well also, and we set it to 0. But later on, like in your engineering design, you have to change this pumping well and see how like drawdown will be affected or not affecting based on this pumping rate or whatever. Like what is the maximum pumping rate that you can have without like with having like a maximum drawdown of 1 meter or whatever this number is. But anyway, so let's just do this one. Like how do, so the pumping rate, that would be like a unit, like create a point object. That would be a point object, and we can just place it anywhere. It doesn't matter. Uh, and then we can we call it like halfway, add a pumping well halfway between B10 and the river. So we don't know where that, like I mean, I just place it anywhere, and then we can select the X and Y later. So like so this is, we just call it like pumping well. I'll call it pumping well, and the vertices. So is giving here like 3, 9, 5, 5. That's halfway between the river and B10, and 9, 5, 0. Yeah. And then like the selected data, no, this is not selected data. This is here, and this is well, and this you put the pumping rate. So from this one to this one, the pumping rate is 0. Yeah, and it's like you select direct. The pumping rate is 0, like you're not pumping anything. Okay, and then you click OK, and then you're, so that, yeah, that's about right. Like you see here is B10. That's like aligned with B10, and it's about half the way from B10 to the river. And one thing I think you can do, you can also show like the name of this thing. Uh, let's see here. If you click on it, mm, how can you show like comments or caption? Yes, like make it visible. So you can, like, if you make this visible, see here, like you see some pumping well. But I mean, you can improve it, like you can make it bigger, like comments, like you can select the font, for example, like make it like 14, yeah, something like this, and you can change the color, make it like red, for example, and then click OK, and then, yeah, something like this, and then you can offset it. Like if you don't like it here, you can say like offset this, like make this like offset it in the, make it like 30, for example, and make this like 20. You can offset it any way you like. Yeah, a little bit better. I know I don't want to waste time, but let's just do it one more time. Here, 15 and 15. I think that's okay. Something like this, yeah, whatever. And I think this shape itself, like you can also change it. Uh, Create like color object line. I think the object line, you can also change it to red, for example. And then, yeah. So you see the pumping well, you make it something that looks like this. Yeah, if you want to. Okay. But anyway, doesn't matter. Huh? Yeah, yeah, sure, sure, sure. Let's take a break. Yes. Yeah, let's take a break. Yeah, sure. Let's take a break. So, yeah. Yes. So you go here. So let's get here to the well. So let's just delete it. Yeah, let's delete this one. So I think if you click on it and delete it, then we don't have it anymore. And then like to add the well package, you just create a point object. You can place it anywhere you like. Let's just place it here. And then I will just call it like pumping well. And then like you set the vertices, which so you can calculate the half distance between whatever and whatever. And then 950. Okay. And then like the mod flow feature, you select well. Oh, okay. Let me show you because you like so that is like so you need to go back to step 1.5, which will tell you go to model mod flow packages and programs. So model mod flow packages and programs, and then boundary condition, and then specified flux, and it was the well package. You have to select this one. And so you select this one, and then if you selected this one, uh, then it should appear here. Yeah, when you do this, it should appear here. But let's do this one. Like let's do this again. Make the command visible. Put it here 20. Change the font to like 12, for example. And then OK. And then I have a pumping well here. Something like this. Yeah. Yes, that's the idea. Like we will have it now for zero because we are just setting up the model. Like later on, you will change the pumping rate and you will see what is the maximum pumper rate that you can have without like causing a certain drawdown. Okay. Yeah. Okay. So let's see where we are now. The river, the pumping well. Okay, so I think the next step is we like upload our field measurements that we will use for testing and calibrating our model to make sure that our model is representing the field condition. Hmm? They don't have? Uh, oh, they do. Like if you click on edit, see they have an undo. Yeah, I think yeah. Here it's here. See this one? Undo. Yeah. Yeah, I mean, it requires some time to get used to it. Like, actually, the first time I ever used ModFlow was here in FGCU when I teach this course. That's the first time, and it took me like yes, it took me a while to learn it. I didn't find it like it took me a while to learn it. I even found some bugs to it, and I emailed like the developer of the software. His name is Richard, and he told me yes there's a bug and he fixed it. He makes actually he told me okay here's a new version where and this guy is great. Like you email him, he just respond to you immediately. And he's a busy scientist. I mean, he's not just like somebody who's just sitting there. He's like a busy scientist, and he will just and he made like he told me okay like he this is a new version like FGCU version. So we had or FGCU version where he fixes this bug. So but he's yeah and he one good, like the guy that's highly recommended. Like the guy, he like at that time he didn't have any like manual for this, but he now have a book like in this groundwater modeling project. He has a book called Groundwater Modeling, where it's an excellent resource to learn this tool and learn groundwater modeling in general. Like, and it is by the developer of this code. His name is Richard. He actually retired. Like, I just got an email, like, I don't know, I think a couple of years ago, like a year ago or so, that he says that he's retiring. So that's probably was one last thing before he retires to give. I think that's I had like one guy I worked with. He was my postdoc mentor in Hawaii. He retired and he also made a book. So I think that's what they do before after they retire. Yeah, they just like everything they learn, they put it in a book, and, and that book was published. I think it's published. It's published. You can buy it. It's also open access, so you can also get it for free, like the book by my super. His name is Ali Al Adi, and the book you can find it online for free. Like search Ali Al Adi and his book, and you can find it online for free. It's a good book, yeah. Also, but highly recommended. Like if you're gonna do this again, get like this book by the developer, like on groundwater modeling, and even for this class, like if you read this book, it will help you to make a better like final like report at the end. Yeah. So okay, so let's do this one. Import head observation. Yeah. So boom boom boom. Where is this? Import head observation file. Import point file. Import points. Ooh, lot of red things. Okay. Specify layer instead of elevation. Instead of elevation. Okay, so you specify layer instead of elevation. Where is that? Yeah, yeah. So yeah, yeah. File import. Yeah, file import, and then after file import, like you control like data. Yeah, it is here. Specify layer instead of elevation, and uh, select specify layer instead of layer. Set value at intersected cell. Set value of the intersected cells. Um, root name. What is root name? Okay, root name. Okay, this is just like what you want to call it. So call it like head observation. And feature. Yeah, head observation package. Okay. Because you are just defining what these points that you are importing is. So you are just telling, you're giving it a name, you're saying this is head observation, head data tape, data tape. Yeah, so in data tape here, you select like open a file, and then like you get like your CSV file, like comma separated file, and this is should be here. No? Oh, see, because I'm selecting like text file, so you should select here comma separated file. Yeah, so now this is the head observation. So yeah, make sure to select like here comma separated file, and then okay, yeah, and then it did it for you, which is mm. Okay, so I think that should be okay. Like what we can do, we can just like I think we can just click OK, and then we will have them here. Let me remove this like background image. Um, how can I remove this background image? Close. Uh, like did we have them or not really? Like I cannot really see them. Let me just do it again. Yeah, file. But they should be imported. I think yeah. You can see it. Okay. Let's see here like in all object. Yeah, head observation. Yeah. 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 So they are here. I think they are just hidden because of the other ones. But that's okay. We can just leave it as is. Yeah. Like if you want to show like their if you want to show like similar to what we did before, like if you want to show their values or their name or whatever, you can just like play with this here. Yeah. Let me just show you an example. So I can make this like red, for example. Can make this here 16. And then if I clicked OK, then see this is B6. Okay. If you want to do this. Huh? Yeah. That's exactly yeah. They have coordinates. So you just imported them, yeah? Yeah, so like let me now like bring it back to let's just make this not visible anymore because we don't need this, yeah. Okay. Yeah. Yeah, you like yeah, when you imported them with their coordinates. So if you go to where can we I mean we will look at this later, like yeah, manage head observation. See, like you imported them like in the CSV file. So that's what the CSV file will contain. It will contain like the head value. Where is and it will contain the coordinates, but like here it does not show the coordinates, but like in the CSV file it has the coordinates. Yeah. Here it just like shows you like uh, and this is the head value. This is what you measured in the field. Remember, like in the field, like you were doing this and measuring. That's the head that you were measuring. Yeah. And then like yeah, if you just want to make sure that this model will reproduce this head, yeah, that you were measuring. Okay. Okay. So. Yeah, so I like this next step. I'm just showing you like you can add details or hide details or whatever. So it's not important. Okay, then model properties. So model properties, import head observation like model properties. uh, like model menu. So you go to model menu, and then from model menu, uh, model layer groups, model layer groups, and then from model layer groups, mod flow layer group, layer type. Where is the layer type? Yeah. So so here, like you see, confined or convertible, you just like this is unconfined, so you select like convertible. And as I told you in this video, Mudflow does not solve like the equation for the unconfined aquifer. What it does is just solve, because it's very difficult to solve this equation, computationally speaking and numerically. So what it does is just solve the equation for the unconfined one and then it correct for the head. It will just say like how much adjustment do I need. Like I know the head will drop by that much, I will just remove it. Yeah, the head will because because like to get the head inside that derivative, that makes it numerically very complicated to solve. Yeah, getting the hydraulic conductivity in that derivative, that's okay. That's what it's doing here. But the head, yeah, because that's now that now become like non-linear. Like now become like a non-linear. Yeah, so it makes it difficult. So just to make things easy, and that's what convertible means. Yeah, here. And okay. So let's what else are we doing here? So mud flow time. Okay. So this is this one. Uh, Mudflow group layer. Mudflow layer, yes, convertible, so that's okay. And then model, Mudflow time. So that's like starting time, ending time, the length. So this is just a steady state, so that's all okay. Steady state. Uh, what's happening here? Yeah, the stress period, that's like in day. We are defining this in day. Double checking. So that's okay. Like I think there's nothing to change here. The If you want to understand like all these different option and what does this multiplier mean and things like this, just read this book and that it will give you like good idea about like all these options. Yeah. And like also how to do this like in a transient and not just a steady state, but and that would be very easy. Like once you did this in that thing, like all these other things, like how to do all these other things, that's really would be easy. But what I'm trying to do here, I'm just trying to make this as simple as possible for you to get like the basic concepts. That's what I'm trying to do here. Not trying to bother you with all like this irrelevant details that you will forget anyway. Yeah. I just want to cover things that I don't want you to forget, which is the basic concepts. Yeah. But, and that's usually the case. Like you see here, I don't remember any of these things because because as I told you, like you might not be doing anything in your career twice. Yeah. You only would remember it when you do it. Yeah. When you do it, you learn it. But what I remember is the basic concepts. Yeah. That's what I remember. But all these detail like select here, click here, I don't remember it. Yeah. Okay. Okay. So like mud flow options, yes, mud flow options. Uh, like you go to here options. I think you need to select. So mud flow option select continue running even the solver closure criteria are not met. Stopping error. Where is this? Continue running. Yes. So that would be like useful for yeah for model calibration, like because you don't want to apply. Yeah, like you just want to finish your run and then keep moving to the next run and next run and next run. Yeah. So that would be for the model calibration mainly. Uh, and then stop error. Yeah, stop error. Okay, and then Mudflow program locations. That was your question, and I didn't do this yet. Yeah. So Mudflow program location. So you see here, I have it in red because I still didn't do it. So I have to see, these are all different models. So like Modflow LRG, I don't know what's LRG. That's like a different type of Modflow. Like I don't know what this. This would be like NWT. I think that would be maybe like a different numerical method, like Newton-Raphson or whatever. CFP. This is for the karst one. Remember, I told you you can have a karst model. So I think this C stands for conduit flow properties. I think that's what it stands for. OHM, OWHM version 1 and version 2, that's like if you want to do farm processes like at a farm and you want to do farm processes and like irrigation and things like that, that's the one mod flow you use for that. Modpass like version 6. Um, uh, See, this is the MT3DMS for Solute Transport. This is the new one for uh, whatever, like structure, like saturated and unsaturated. Zone budget, that could tell you something about like your zone. But again, like we just like, and this Modflow 6, which we don't have. So I have this one. Uh, let's just put it somewhere. I downloaded them already like a few days ago. Uh, Lessons, field methods, numerical modeling, yeah, codes. So I downloaded them here. Just like what you do is you extract all. So I can extract it here. And when you extract it, I think you will find the Modflow manual. You will find the Fortran codes that you can compile. You will find the compiled versions, the executable one. You will find everything. Yep. So like this is this one. Yeah, like you go to the pin and that will have like the Modflow 2005. So I think that's the one you need. So you copy this one and I have to see where, I mean, you can select it from anywhere. Yeah, I mean, I can just select it from here. Yeah, I don't need to put it there. Like, so you want to do this? Yeah, just let's select it from here. I don't even need to put it there. So like you come here, you come to Modflow program locations. Let's just select it from here. Yeah. So we come here like to my desktop, my data, my teacher, my groundwater hydrology, this one, lesson, numerical modeling. You can just select it from anywhere here. Mod flow, go to the bin, and then I select this one. I mean, very long path. Like, if this path, that's, oh, see here, this has a dot, so that might not work. Like, see this dot here? That could create an issue. I think that's that is like, you see the dot here? This dot here. That could create an issue. That's like that's the area. But let's try to run and see if we're gonna get like this issue or not. Maybe, yeah, yeah. But so yeah, so here we might get this issue, but let's try to run the model and see if we got this issue, then we can, or let's not waste time, like, because if we know we're gonna get this error, let's just put it where it will not give us an error. Yeah. So so mod flow, and I told, like, I think where is that? Like, where did I put it? Like, where did I put the mod flow? I don't know where did I install this one. Do you see model muse here? No. Yeah, I mean, I don't know. Okay, how about this? Let's just get this guy from here, copy. Let's just put it here in our project. Project files. Let's call it like codes here. Okay, now that will not give us an issue. So like you come here and then you come here, models, package and programs. No, models, uh, program location, and then I will like come here, come here, come here, come here. Field methods, no numerical modeling, project, project file, codes. Okay, here we go. I think that should be okay. And then click OK. Any other checks we need to do, like select running, manage parameter for double checking? Yeah, so we can do like manage parameter. We did this already at the very beginning. Yeah, that looks okay. Okay, manage parameter for double checking. Okay, now we have to select like the initial condition, and initial condition is not required because that's like steady state. Yeah, and that is like flow model. You generally, yes, you don't really need like the initial. I mean, yes, for steady state you don't need initial condition, but for transient state, if you didn't put like the initial condition, like your first few years or whatever might not be correct, because for like the model to like catch up, yeah, from wherever you're starting, it might not be. But for steady state, it really doesn't matter. Like for steady state, like we still need to put the initial condition, not because like the accuracy of the solution, but because of the solver. So if the solver is starting from a good starting point, it will converge faster. Yeah, that's just for the solver, but not for the accuracy of the solution. Yeah. Uh, uh, but for the transport modeling, you need initial condition. Yeah. For flow modeling, you don't. But for transport modeling, you need. Okay. So data menu. So like you go to data here, and then edit data set, required hydrology, and required hydrology, mud flow initial head. Yeah, mud flow initial head. Initial head. Where is this mud flow initial head? Required hydrology. Where is that? Oh, here. Yes, yes, yes. You're right. So you will just put 111, something close to your expected solution. That will make your solver converge faster, because it might not even converge at all. Like if it's starting from something very far away, it might not even converge at all. Anyway, so now it should run. Yeah, if we run it, it should run. So let's try to run it, see if it will run or not. Uh, uh, it says like save. Uh, so this is like now you are saving your MudFlow models. Are we doing this here? Yeah, like I think. Yeah, like let me just cancel. I think what I wanted to do, I just wanted to put this inside here, but it doesn't matter really. But like, see, like this is a project file. I wanted to have everything model. setup. I wanted to have everything here, but the thing is like what you can do, like yeah, like I want let me just move it. Like let me close this one. So I will close the project. You want to save? Yes, save it. So I will close it, and then like the project is just MS. Like you have everything here, and like so model setup. So I don't know what's happening here. Where did I put this? Okay. So like we are doing this here. That's like the model setup, because let me just move this one here. I don't even know what these are, but let's just call this like project file, just some organization, yeah. And for your project, like all you need is this one. Yeah, that's all you need. Yeah. Like now you see you don't have any like you see you don't have any Mudflow files. Once we start like running Mudflow, that's what this graphical user interface will do. It will take all this data that we inputted it, and it will write the input file. It will run Mudflow, and it will write the output file. That's what it will do. Yeah. So we can see this now. So like now you just have like this graphical user interface and all this like things that you entered. Yeah. So now let's try to run this and see if we can run it successfully. Now see it is telling you like Mudflow file name. So this name file, this is a name file. It has the name of all the packages that Mudflow will need to run. Yeah. Like your input packages and your output packages and also on and so forth. Yeah. And now what Model Muse will do, it will write the Mudflow file and all these packages. So uh, yeah, so it seems to be working. Yeah, so it seems to be working here. I think so. Uh, where is that? Like just saw something happening here. I don't know. Yeah, here you see like it has like uh, one thing. Yeah, see it's like Mudflow. Did it run correctly or no? Yeah, it seems to be running. Yeah. So now this is the LST. Let's just go see here what happened here. So what it did, it created like see all these input files. All these are the input files that you need to run Mudflow, and it will create. So after you, so it will create like all these input file like this name file, for example, that will let me show you like this one. So like this name file that will have all the packages that you need to run Mudflow. So you have this LPF, you have the well package, you have the river package, the recharge, the package, the zone, and blah blah blah. Okay, but and then so that is the one like LST. This is the output file of Mudflow, and so that will be the output file, and that will tell you like it will tell you here this is your grid. It will tell you like all this input. It will provide like a summary for like all these inputs. These are the different hydraulic conductivity zone, like zone one. That's why remember like you say like true and false. So false that would be zero, true that would be the one, and so on and so forth. Uh, here is that's the hydraulic conductivity values themselves. Yeah, remember like these numbers 21 blah blah blah. Yeah, that's the hydraulic conductivity value. Um, that's the river package. Uh, so this all like the input package that you wrote, and like I think this is this one is important. Like this will show you like the water budget. Remember, like water budget, what comes in be equal to what comes out, and that's exactly what you have here. So what is coming in, it mainly coming out from like your recharge, and what's going out would be going out through like your river or like your, yeah, because you only have, yeah, everything goes like, that's the only boundary where it comes from. And like these two should sum to zero. Not exactly zero because there are some numerical error, but almost zero. Like you see here's this number here, like, so that's like the in is like there's no change of source. Like the in is just coming from here. The out is just like leaving. Nothing is leaving from here. The out is leaving from the rivers. Yeah. And then if you sum these two, like in minus out, you get like zero, almost zero. Yeah, because there are some numerical errors. Yeah. But that you get this. This means that your budget is correct. Yeah, your water budget is correct. And here is very simple. But in other situation, you might have more items. Like you could have spring discharge, submarine groundwater discharge, pumping. So that pumping that would be coming out. Yeah, the N it could coming from injection. Here is coming from recharge. It could be coming also from like the river, because sometimes the river could be like gaining a stream or losing a stream. In that case, it is a gaining stream. Yeah, it's taking the water, but sometimes it's also a losing stream. It's like recharging the groundwater, especially when you have pumping. When you have pumping, you will not release water from storage. Actually, you will be capturing this water from nearby bodies, from a lake, from a river. Yeah, that's what happens. Yeah, here, have more. Yeah, yeah, yeah. So that is usually, and see, like if you look here, percent discrepancy, zero. Yeah, that's like zero. But here, this is the important part. Like uh, this is the important part. Like, see, this is the observed value. This is what we observed in the field, and this is what my model is simulated. And here is the difference. So you see here, you have about like half a meter difference. Like, remember in your project, I'm telling you, I want the difference between these two to be like 30 centimeter or something like this. Yeah. Now here, it is like my model is kind of like this is the simulated value, this is the observed value. So I like the head is a little bit higher than what I should be getting. Yeah. So I have like this difference. Here it's perfect, like the same, almost the same. Yeah. It's like so the difference is zero. Yeah. Here is about 27 centimeter, which is, so this is in the limit. This is in the limit. Like all these guys are in the limit, like of 30 centimeters that I'm telling you. Yeah. This one is a little bit up. This one is a little bit up, like so. These two are up. So what you can do this manually. Like you change the hydraulic conductivity value, and then if you change the hydraulic conductivity value, so let's see what's happening here. So here, like see Darcy law, like Q is equal to negative K H, yeah, like delta H over delta whatever X or whatever. So now here, H, I want like, this is the observed, this is high, yeah? So like this is high. So if I want to bring this guy down, so to bring this guy down, I need to increase the hydraulic conductivity. Yeah. If I increase the hydraulic conductivity, this guy will go down. Yeah. That's how. So like if I go to B1, then I increase it. But then the problem is if I just increase the hydraulic conductivity of this one, that could affect the other one, could mess up the other ones. That's why we need to do automatic calibration. Otherwise, we will go crazy. Yeah. Like you fix it here and then it goes like screw up from here and then you fix. But that's the general idea. Like if I want to bring this guy down, I raise this one up. Yeah. So we can try it manually. Like we can, like if you want to try it, but let's not waste time. You just understood it. Yeah. That's so you're probably tired and you want to go home. Yeah. So let's not waste time. You probably understood. So that's the first thing I want you to understand. The second thing I want you to understand is this. This is called like your objective function, yeah, or like your sum of square error. So basically, that sum of square error, had like sum of square difference. Like remember we talked about this. Like when you run an automatic calibration, you just want to minimize this one. Yeah, like you want to bring this one to be the minimum, like as minimum as you can get it. Yeah, you cannot get it close to zero, but let's write this number down and let's look at it after calibration. So now it is like 9.21 e to the power minus 1. Yeah. uh, after you like we calibrate our model, that number would be much smaller. And like how do we calculate this number is just exactly like sum of square differences. So like see, this is the difference. Yeah, you square them and then you sum them and then they should give you like this number. Yeah, that's the sum of the square differences. Or sometimes it's like root mean square error. Like like you will square them, you will sum them, and then you take the square root. Yeah. Here you are just summing them. Yeah. But like you can do it like if you like these differences, like if you like square these number and sum them, they will give you this number. And you can try it now like with Excel or whatever. Yeah. But let's not waste time. But that's basically, so this is just like a measure of all these together. Yeah. And that's like if you're running automation, that would be like that's exactly what PEST is doing. It's trying to minimize this number by minimizing like its individual components. Yeah. That's what BEST is doing. But let's write this. This is like 9 point whatever. After we calibrate our model, that would be something much smaller. Yeah. Uh, it's already, yeah. So let's okay. So I think that's for this part. Like, do we need to do anything else? Let's see here. And you can see this number here also. Like you can, these are like different iteration. Like you find like a lot of them because like at like a different iteration of your solver. So it's like showing you the numbers here. Uh, See, that's like the same things that you see here. I just want to show you like the sum of the square difference somewhere else. Yeah, but that's a basic concept. Like the most important thing in this file is like you look at this number here, like these numbers here, and like your budget. Let me just get rid of this message because it's annoying. Okay, so let's keep moving. So here, this is our model setup. Let's do another one, like, and call it like uh, model calibration. Or I think we still have some steps here, yeah? We still have some steps here. So uh, sum of the square difference. Yeah, so save the models. We can save it. Okay, that is like giving us warning. I mean, this okay? Like ratios, that's okay. This is just like it's just telling you the ratio. Like what is do you want to create model archive? Okay, create a model archive. It's basically like this warning is telling you that there is a sharp contrast between these cell. Like it's 10 centimeter, 10 meter, and then suddenly it jump it to 50 meter. So it's telling you make it more gradient like transition. Yeah, that's what it's telling you. But it doesn't matter. Yeah, as long as your model is running and converging, it doesn't matter. Okay. Uh, let's let me stop.